Today our focus is going to be on drawing inferences from valid and representative samples with proportions. What is an inference? It is an interpretation that is based on a set of information or data. Inferences can be used to make predictions. Notice that we're making a prediction or an inference, or another way of saying it, an educated guess based on data. That doesn't necessarily mean that our prediction will come true. It just means that the data is suggesting that it is likely to be true. Now, remember that when we're doing proportions, we're setting up in a ratio, part over a whole being equal to a part over a whole. And so we want to look at our data, and one of our ratios is going to be the ratio from our sample, and the other ratio is going to be the ratio from our population. Now, let's talk about what our parts and our wholes are. Our part, that's the expected outcome that we're looking for. And this is a good time for us to get used to the language. Sorry, that got a little tight and messy. We will talk about expected outcome again and probability. And you'll see a lot of overlap with what we're talking about here with predictions when we get to probability. So the part is going to be the expected outcome. That's what we're looking for. The whole is going to be the entirety of the sample. So we could say whole sample size. Now, when we get to terms of population, this is generally where our prediction comes. So that the part is, again, the expected outcome / prediction out of the whole, where this is the sample size of the population. So let's look at an example. Lucy took a survey of her friends' favorite colors. Here's what she found. 5 friends like red, 7 friends like blue, 3 friends like yellow. If Lucy asks 50 friends about their favorite colors, how many friends can she expect to prefer blue? So we want to set up a ratio. Our first ratio is going to be the expected outcome. Well, what is our expected outcome? How many friends can she expect to prefer blue? So our expected outcome is blue. Well, our expected outcome for our population is also going to be blue. Come back to our sample. Our sample data is given in the chart here. And so we can see that 7 people preferred blue. How many total people were in the sample? 3 plus 7 is 10, plus 5 is 15. So 15 friends in the sample size. Well, we want to set that equal to another fraction. In our other fraction, do we know how many preferred blue? No, that's what we're looking for. That's what the question asked. How many can she expect to prefer blue? If Lucy asks 50 friends, well, what does 50 friends become? That is the larger quantity of friends, so that is our population. Well, we've now set up a proportion. We set a ratio equal to another ratio, and we have an isolated variable. Now, we can solve any proportion, and hopefully you remember that you can solve proportions by multiplying across. We call this cross multiplying. So 7 times 50 is 350. 15 times x equals 15x. And so we want to get x all by itself, and since x is currently multiplied by 15, we're going to divide both sides of the equation by 15. So x is equal to 350 over 15. Now we could certainly simplify that and get 70 over 3. However, remember at the beginning of the year I told you an improper fraction is always a sufficient answer, except for when we're dealing with word problems. Because we're not going to have 70 over 3 friends. So we need to convert that to a mixed number at least, but I would probably go ahead and just convert it to a decimal so that we can get an actual numeric value that we can simplify. So x is approximately 23.3 repeating. Now again, we've got to understand what 23.3 repeating means. That means I have 23 friends and I have a third of a friend. So am I going to take the arms off of a friend and just expect that that arms from that friend prefers blue? No. At this point, we've got to do some rounding and approximate our value. So we would round down. X is equal to 23 friends. We could expect that 23 would like blue. Sandra found that after surveying 20 people, only 4 people stated they preferred hot dogs over pizza. If Sandra surveys her entire school of 300 students, how many can she say expect to prefer hot dogs over pizza? So again, we want to set up a proportion. She surveyed, so that's going to be our sample, right? That's where we get our sample, is by doing surveying. 20 people. That was the total sample size of how many people she surveyed. And 4 liked hot dogs. Now, if she were to survey the entire school, well, entire school ends up being our larger group. So that's going to be the population. How many can she expect prefer hot dogs? X. So we want to cross multiply. 20x is equal to 1200. All right, 20 is multiplied to x, so we want to divide both sides by 20. My 2's will cancel out, 2 goes into 1, or sorry, my 0's will cancel out, 2 goes into 120 60 times. So x equals 60. Now let's interpret that. If she surveys the entire school of 300 students, 60 would prefer hot dogs. Marcus surveyed his math class, and in this class, 25% of the students stated they like gum over chocolate. He wants to publish an article that says chocolate is the most preferred form of candy. Explain why he cannot make this prediction. Now I want you to pause the video and come up with 1, maybe 2 reasons why he can't make this prediction. All right, welcome back. Why can't he make this prediction? Well, since I can't ask for your responses, I'm going to have to point out some of the, one of the most obvious. He wants to publish an article that says chocolate is the most preferred form of candy. Now, did he identify his population? No, he did not. So he's making a definitive statement that applies to the entire population, to everybody. Now, if he surveys his class, which is a very small group of people, can he make a statement that applies to everyone? No, he can't. Now, the other error in this, 25% of the students said they like gum over chocolate. Doesn't give enough information to indicate that chocolate is the only other preferred candy, and that chocolate would be the most preferred. But we're going to stick more predominantly to this one so that we can say that the sample is not representative of the population, because we said the population was everybody. Carly needs to have a 10 test average of 95 in order to take Algebra 1 GO A in 8th grade. Using the information from her first 9 assessments, what is the minimum grade she must get to make it into this grade? All right. We're looking at averages in this particular problem. Now, in order to solve this, we are trying to figure out if I add up all of these 9 grades and I add a 10th test, what do I need in order to get an average of 95? So we're pivoting just a little bit here. We have 98 plus 89 plus 93 plus 95 plus 92 plus 100 plus 95 plus 95 plus 97 plus something, and we want that to all equal 95, but remember, averages is divided by the quantity of test. So we're dividing by 10 tests. Now we want that all to equal 95. Well, what's our plus something? What number will sit right there that's going to make this entire expression equal 95? That's what we don't know. So when we don't know something in algebra, we plug in a variable. And at this point, we can start to simplify. So let's add these numbers together. 98 plus 89 plus 93 plus 95 plus 92 plus 100 plus 95 plus 95 plus 97. That gives me 854. Plus my 10th test, which was x, divided by 10 equals 95. Well, for a lot of you, this should look like a two-step equation now. We need to get the number out of the denominator, and in order to do that, we multiply both sides of the equation by 10. When I multiply the left side of the equation by 10, the 10s disappear, so 854 plus x is equal to 950. And now we're down to a one-step equation, and we simply need to subtract 854 from both sides. So x is equal to 96. Now, if I don't see this work on your paper, when you solve a problem like this, I will count it wrong. This is not a guess and check. Let me plug numbers into the calculator type of a question. This is an algebraic equation that helps us to determine the value of the missing variable. Algebra needs to have a 10 test, or Carly needs to have a 10 test average of 90 in order to get into Algebra 1 in 8th grade using the information from the first 8 assessments. What is the minimum grade she must get on the final 2 tests to qualify for this? So now notice we have the same situation. This time I'm going to go ahead and simplify things and add these all up. 98 plus 95 plus 100 plus 98 plus 92 plus 85 plus 95 plus 93. So all of these together add to 756. And notice that there are 8 tests there. But we have 10 tests that we need to account for, right? So plus 1 more plus 1 more equals 90. Same process. We're going to combine our like terms. So 2x plus 756 over 10 is equal to 90. Now we will multiply both sides by 10. So 900 is equal to 2x plus 756. So now we're going to subtract 756 from both sides. And 2x is equal to 144. So now we're going to divide 2 on both sides. And x is equal to 72. Now, it is possible that she could get a 72 on both tests and still qualify with the 90 average.